Alright, today we're talking about simplifying square roots. Now, as we've seen, not all numbers can you find the exact square root of. Some numbers, such as 20, there's no whole number that we can say the square root of 20 is this. We can get a decimal approximation, or what we're going to learn how to do today is we're going to learn how to simplify these square roots so we can get a simpler version, maybe a closer approximation. So I have 6 examples for you. And the good thing about this today is it's kind of a concept that you already know how to do. Now your book talks about a different way to simplify square roots, but we're going to learn a different way. So let's say I want to simplify the square root of 63. Now first, ask yourself, is there any number times itself that will give me 63? Okay, well I know 8 times 8 gives me 64, 7 times 7 gives me 49, but there's no number times itself that I can get 63. So what we're going to do is we're going to cake this number. So if you remember, whenever we build our cake, this is just like whenever we were doing our prime factorization. You are going to put your number, and you're going to draw a line to the left and a line underneath. We're going to add our first layer. Now the number one rule is that you can only take out prime numbers. So I'm looking for a prime number that I can divide out of 63. Usually the two easy ones are 2 and 3. Okay, well 2 will not go into 63, but I know I can divide out a 3 from 63. When I divide a 3 from 63, I get 21. And we're going to keep going. I'm looking for a prime number I can take out of 21. Hopefully you recognize that I can take out another 3. 21 divided by 3 gives me 7. Okay, prime number I'm going to divide out of 7. There's only one of them, and it is 7. And 7 divided by 7 gives me 1. And remember, once you get that 1 on the bottom, you kind of have your upside-down birthday cake, and you are done. Now before, if we wanted to write the prime factorization, what we would do is we would say 3 to the second power times 7. Okay, we would multiply those out. We're not doing that this time. What we're doing now is we're looking for pairs. Okay, if a number has a pair, like these 3's, they get to go on the outside of the radical sign. So since I have a pair of 3's, that tells me that I can write 1 3 on the outside of the radical sign. Now, anything that doesn't have a pair has to stay inside. So that 7 has to stay inside. So if I wanted to simplify the square root of 63, I could also rewrite it as 3 square roots of 7. So if you plug square root of 63 in your calculator and you plug 3 square roots of 7 in your calculator, you'll get the exact same decimal approximation. Okay, so it just takes a little bit of practice. So this time, let's look at the square root of 24. Okay, always check, is there anything times itself that can give me 24? Hopefully you roll everything out. Can't do it, so we are going to cake 24. So I'm looking for a prime number I can take out of 24. Okay, so hopefully you're thinking of 2 or 3. It really doesn't matter which one you start with. I always start with the smallest one. So if we start with 2, 24 divided by 2 gives me 12. Looking for a prime number I can take out of 12. I can take out another 2, and we get 6. Alright, well I'm looking for a prime number I can take out of 6. Well look, I can take out another 2. 6 divided by 2 gives me 3, and then whenever I'm left with 3, the only prime number I can take out is 1, which leaves me with my 1 and my candle at the bottom. Okay, so now remember, we're looking for pairs. Now I can only circle pairs. So although I have 3 2's right here, I can only circle them and put them on the outside of my radical if they have a pair. So anything that does not have a pair, this 2 and this 3, we're going to put on the inside of the radical, and we are actually going to multiply them. So on the inside of my radical, I'm going to take 2 times 3. So my simplified version is 2 square roots of 6. Okay, let's do the square root of 48. Okay, so once we rule out that it's not a perfect square, let's go ahead and cake it. Okay, so looking for some prime numbers I can take out of 48. Actually, I want you guys to go ahead, build your cake, and then stop. So once your cake is completely built, pause the video and I'll talk you through setting up your simplified square root. Alright, hopefully your cake looks like this. Okay, so remember, we want to go through and circle pairs. Now I notice I have a pair of 2's, and look, I have another pair of 2's. So what we're going to do is this pair of 2's gives me 1 2 on the outside of my square root. This pair of 2's gives me another 2 on the outside of my square root. Then on the inside, we're going to put anything that is left over, which is a 3. So my simplified square root is 4 square roots of 3. Alright, let's throw some variables in there. This one's going to get kind of long, so just a warning, you might want to write kind of small. Let's do 200 j squared g, and I want to find the square root of this monomial. Okay, so we're going to write the whole thing over here, and we're going to cake this whole thing. Let's just look at our numbers first. Okay, if I'm looking for a prime number, I can take out a 200. Let's start with 2. I get 100 j squared g. I can take out another 2, and I get 50 j squared g. Take out another 2, I get 25 j squared g. Take out a 5, I get 5 j squared g. And then I can take out another 5, and I get 1 j squared g. Okay, so my numbers are done. So what we're going to do is we're going to look at my monomials. Now, I can take out a j. Remember, we want to take them out one at a time. And I'm left with j, g. If I take out another j, I'm just left with g. And then I want to take out a g. G divided by g gives me 1, which means I'm done. Okay, we're going to do the exact same thing. We are only circling pairs. So I have a pair of 2's, I have a pair of 5's, and I have a pair of j's. So each one of these gives me a 2, a 5, and a j on the outside of my radical. On the inside, I'm going to put anything that's left over, which means a 2 and a g. So if I simplify this, my simplified square root should be 10j square roots of 2g. Alright, now the last thing we're going to do today is learn about simplifying square roots that are division problems. So I want to simplify the square roots of 7 over 25. Okay, now here is a rule that we haven't talked about yet. If I have the square root of 7 divided by 25, that means the same thing as the square root of 7 over the square root of 25. Now, if I look at the square root of 7 over the square root of 25, well, what is the square root of 25? Hopefully you're thinking 5. And the square root of 7, since 7 is a prime number, I'm not going to be able to simplify this, so this is how you would leave your answer. Let's do one more like that. Let's look at the square root of 400k over 625c squared. Okay, remember, the square root of a division problem means I can take the square root of the numerator over the square root of the denominator. Okay, now before you start caking numbers, I would check out your perfect square chart because hopefully you notice that 400 is a perfect square. The square root of 400 is actually 20. So if you look at that rule at the very top of your notes, if I have a product inside a square root, I can break that up. So instead of taking the square root of 400 times k, I can take the square root of 400 times the square root of k, and likewise in the denominator, I can take the square root of 625 times the square root of c squared. And then if I go through and simplify each one of those, the square root of 400 is 20. The square root of k, I can't do anything with that, so I'm just going to leave it as a square root of k. And the square root of 625 is 25. And the square root of c squared is c. Remember, the square root and the square root cancel each other out. So this is how you would leave your answer.